Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 13. Let's consider this network consisting of 6 resistors labeled R1 through R6 as well as 3 independent voltage sources VA, VB and VC. The question now is to find the currents through each resistor. Let's move on to the solution. Let's start first by labeling all the nodes in the circuits, and I will consider this as node 1 and this as node 2. After, we will assign the voltages V1 and V2 respectively to those two nodes. Next, we need to select a reference node in the network. The reference node is typically chosen as the node with the most connections or as the ground node. Let's assign now arbitrarily the currents in each branch, and I will consider I1 is the current through the resistor R1, I2 is the current through the resistor R2, I3 is the current through the resistor R3, I4 is the current through the resistor R4, and I5 is the current through the resistor R5, and the last one, I6, is the current through the resistor R6. Next, we will proceed to apply Kirchhoff's current law in each node. Let's start first with node 1. By applying Kirchhoff's current law at node 1, we can write I1 is equal to I2 plus I3. Let's move on to node 2. By applying Kirchhoff's current law at node 2, we can write I3 is equal to I4 plus I5. And according to Ohm's law, the current can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the currents can be found by the following equations. I1 is equal to VA minus V1 over R1, and I2 is equal to V1 minus VB over R2, and I3 is equal to V1 minus V2 over R3. I4 is equal to V2 minus 0 over R4. I5 is equal to V2 minus VC over R5, and finally I6 is equal to VA minus VC over R6. Now, by substituting A, B, and C in 1, we can write VA minus V1 over R1 is equal to V1 minus VB over R2 plus V1 minus V2 over R3. By replacing the resistors and the voltages with their numerical values, we obtain this equation, and if we continue simplifying this equation, we obtain finally negative 7V1 plus 2V2 plus 22 is equal to 0. And now, by substituting C, D, and E in 2, we can write V1 minus V2 over R3 is equal to V2 over R4 plus V2 minus VC over R5. And if we replace the resistors and the voltage with their numerical values, we obtain this equation. And if we continue simplifying this equation, we obtain finally 5V1 minus 8V2 plus 6 is equal to 0. Now, by performing 4 plus 2 times equation 3, we obtain one equation in terms of V1 is negative 23 V1 plus 94 is equal to 0. That means V1 is equal to 94 over 23 is equal to 4.08 volt. And from equation 4, we can write V2 is equal to 5V1 plus 6 over 8, and if we replace V1 with its numerical value, we obtain V2 is equal to 3.3 volt. And now from equation A, we have I1 is equal to VA minus V1 over R1, If we replace VA, V1 and R1 with their numerical values, we obtain I1 is equal to 0.48 amps. And from B, we can calculate I2 is equal to 0.08 amps. And from C, we can calculate I3 is equal to 0.39 amps. And from D, we can calculate I4 is equal to 0.33 amps. And from E, we can calculate I5, and I5 is equal to 0.06 amps. And the last one is I6 is equal to VA minus VC over R6 is equal to 1 amps. After completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. This is the independent voltage source VA, VB, VC, resistor R1, R2, R3, R4, R5, and R6. I connect here a voltmeter to measure the node voltage V1, and here a voltmeter to measure the node voltage V2, and here I put ampermeter 1, 2, 3, 4, 5, and 6 in order to measure the currents I1, 2 through I6. Let's move on now to analysis. This analysis, calculate nodal voltages. We can see here that I1 is 478.26 milliamps, is almost the same value we have done by calculation. For I6 is 1 amps. V1 is 4.09, is almost the same. V2 is also almost the same, and I2 and I3, I4 and I6 are almost the same. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. Take care and see you next time in another video. Bye bye.